All right, so now let's talk about repair techniques, all the fasteners that go into it, and what, how you go about repairing a composite structure, how you restore it back to its original state, and how do you install new fasteners if it need be. What are some cares? What are some concerns? What are some things that we need to look at? All right, one of the coolest things about composites is the just low barrier to entry when it comes to tooling. Now, there's a lot of things that you can do with like hot bond kits, CNC machines, and all kinds of stuff. But to just do the basics, you only really need a pair of scissors. And that's kind of like the one thing that you just got to have because you have to be able to cut the fabric. But other than that, there's all kinds of different ways you can go about cutting it, but none of the tooling is really that expensive. So just a basic set of hand tools that you could probably already have at your house will get you going to actually do any kind of like composites work. Okay, so if you decide that you want to upgrade your tooling, go with air tools. The reason being is that carbon fiber, as you cut it, can be in can get inside of your like electric drill, and it'll cause it to short circuit. And so because it's conductive, so air tools basically kind of prevents that from happening. And you'll definitely, especially if you're going to be doing any repair work, you're going to have some sort of advanced tooling for it for cutting and drilling and doing all that stuff. You can't just simply use the hand tools forever if you're going to be professional about it. And so air tools is definitely something that you want to go stay away from electric when you're working with composites. Now, for the rest of the materials that you need, it's easier just to talk through it. So this is a infusion mold that's going in. It's going to be a spinner for an aircraft. The if you start looking at the parts and pieces that are being used here, you start off with just a mold, so like a negative of the part that you're going to place. You then lay the fabric in it, and then tape a vacuum bag over the top. The vacuum bag is then going to be hooked up to a vacuum that will suck it down. Now, as it sucks down, you've created a lot of negative pressure in there. And in this particular setup, we're doing infusion. So it means that like there's a vacuum that's been drawn on the fabric itself, and we're going to turn on a pump or a line that goes to the resin. That resin is going to get sucked into where the fabric's at, and as that the vacuum is being pulled, it's going to pull the resin out of the reservoir into the infusion material, and then out into the rest of the carbon fiber part. Now, this is probably the most superior way to actually infuse resin into material, but it's not the only way. It's probably the most advanced way, and it's definitely the way that is going to require the most equipment, because you have to have the vacuum bag, you have to have all the pump and the materials and the lines and all that good stuff. But while it does produce a good quality product, it's not necessarily the best way. It's just a way to go about doing it. It has its pros and cons. Now, infusion's great, but it's pretty advanced. You end up having to have a pump. You have to have a vacuum line, then an inlet line for the matrix material to come into. You have to have pressure canisters. You have to, and then on top of all the released film, the tape, the vacuum bag itself, and all the regular handling, materials. It's definitely a lot cleaner than some of the other approaches, and it definitely, for more complex parts, it will 100% the fusible like infusion materials help guide the matrix material to certain areas, and so you can get to parts that are a little bit more difficult to reach with a traditional vacuum bag approach. It will definitely have the most uniform, outside of pre-preg, the most uniform matrix setup that there is. However, it's complicated and it is expensive. So the most common one to actually be used is what you see here. It's just called a wet layup, and you can see the simplicity of it. You have the carbon fiber laid out, or your composite material of your choice laid out on some release material, some material where the matrix is going to adhere to it, and then you take your matrix and you simply just goop it on there. Now, there is a technique to doing this correctly. You don't want to have too much matrix, and you don't want to have too little matrix. You're looking for just the right amount, and you just have to practice it, and you kind of get an eye of what a properly done wet layup looks like. And you'll do one of these in class. It's not that difficult to do. This is a good place to just learn how to mix the matrix and apply it appropriately. But that is a wet layup. The only real materials you need is just whatever the carbon fibers will lay on. You need gloves. You need something to spread it. Ideally, one of those little spreader bars that the guy's using in the picture right here. And then your carbon fiber, or fiberglass, or aramid, or whatever it is you're going to use to build the part with. And you just spread it on there. It's really that simple. Okay, so if you wanted to step up the quality of a wet layup and get the best fiber to matrix ratio as possible to kind of get a higher quality part, you want to throw a vacuum bag onto it. Now, there's nothing that's really that different about a wet layup and a vacuum bag. The big difference is just the addition of the vacuum bag. You're going to do all the same things, but then you're going to put the bag on top with it taped down on all sides. And it's going to have a line that runs from the vacuum bag to the vacuum pump, and all it's just going to do is just push. It's going to suck the air out of that whole system. Now, as it goes, it's going to pull any extra air that may be laid up inside of the fiber, and resin will take its place, and it will. What the result will be a nice uniform part. That's far superior than a wet layup. So you don't want it to use it in like cosmetic places, simply because whenever you release the bag, it's going to look a little not the best on the surface, but it is definitely going to produce a higher quality part than your wet layup. So just something to keep in mind, that you can always throw a vacuum bag on a wet layup if you wanted to increase the quality of it, but it is an extra hassle. It is more equipment, all that good stuff. So you don't have to use it unless whatever job you're working for calls it. But there you go. Now, the other approach that you could take besides infusion or a wet layup with or without a vacuum bag is to use a pre-preg, which we've talked about before. Essentially, that's all it is fiber with the matrix material already infused into it. You store it cold, you bring it out and pull the release film on it, and then eventually it'll start to set up. Now, you can do room temperature out of autoclave pre-pregs layups that it'll take a day or two to just harden up like you would with a wet layup. Or you could speed it up by sticking it into a big oven called an autoclave. Now, those different matrix materials and pre-pregs will all have their own kind of temperature band that it sets up in a certain period of time. Uh, the all the autoclave really does is just help speed it up. And so most of you guys probably won't encounter this unless you work at a place. And if you do work at a place that has an autoclave, then they're going to have somebody there that's going to know how to run it, and they're going to know exactly what you're doing, because it's all very, very expensive. You can make your own. I've seen that before, where people kind of built their own autoclave and just kind of use it as kind of like a little oven to get their parts set up. That works. So that's something you could also get into if you wanted to. Yeah, so that's an autoclave and pre-preg, both in and out of an autoclave. Now, probably the most famous example of an autoclave composite layup is the F-32. This was the plane that Boeing put up against Lockheed's F-35 and eventually lost. But the entire upper portion of the wing was carbon fiber, and this is the autoclave in Tukwila where they set up. I've actually stood in this thing. It's pretty big, but what they would do is that they would lay that wing up, increase the heat, increase the pressure, so that it would set up over time. And one of the reasons why the plane lost the bid, and there's a lot of them, but one of them was that was the only autoclave in the world that could actually produce that one part, and so that it became a single point of failure that the whole DoD, because it was the Joint Strike Fighter, so all the branches used it. They didn't want to to put all their eggs in one basket, so to speak. But that is probably the most famous autoclave that I am aware of, at least. Okay, so here is a repair of a part that is ongoing. They're using a vacuum bag technique on that bear. So it's not just for manufacturing or not just for building stuff, but you can take any one of those techniques and apply it to a repair. Because effectively, all of a repair is doing is just returning that part back to its original state. So it kind of has to go through the remanufacturing process again. So the preferred way to do it is just do it with vacuum bag. What you're going to do is you're going to cut out the area. You're going to go off the engineering data that says like this is how the layup of those plies went. So you remember like that it might be like negative 45, positive 45, 0, 90, 0, positive 45, negative 45. That's just kind of an example, and it's all going to be based on how they want the part to warp or how they want the strength to run. So you're going to match those plies with you're going to cut the area out, build up a repair plug that matches that ply orientation, slide it in there. You're going to take your matrix material. It should be nice and tacky, and then bleeding out the sides to meet up against the sides of that part. You put the vacuum bag on there, and you're going to vacuum bag it. Now, if you really wanted to set up quickly, you could autoclave it. There's nothing saying that you can't do that. Most of the time, however, you might use just hot bond kit, so that's a vacuum pump that also heats the part as well. So we have two of those here in the hangar, so you'll play around with those a little bit. And that's very common. I remember when I first went into to work at Aviation Technical Services, the whole first floor, whole like west end of the first floor of the facility was a couple of little old grandmas that all they did was composite repairs on a regular basis. So they would take parts off the jet, and they would cut out pieces that didn't work, match the repair piece to the engineering data, put it in there, vacuum bag them up, and off they go. And that's really all there is to it. Now it's just kind of like sheet metal that there's definitely an art to doing it well, but the basics of composite repair is actually pretty straightforward, pretty simple, and you don't even have to vacuum bag it. You could always, the way we did it in the Army would be to just cut the piece out, match it, and we used a lot of honeycomb there, and so there was that component as well. But you would build your little piece, stick it in there, and then we would just put resin over the top and let it set up, so that way it's solid, and then come back and sand it down. And do it that way, and that's basically all that is a wet layup. But this is a wet layup plus a vacuum bag. You could always throw it in an autoclave and accelerate the cure time a little bit, and that'll work as well. But long story short, the basics of repairs is just like manufacturing, and they're not really that difficult to do. If you can do a layup, then you should be able to do a repair anywhere else. Yeah, so that is the basics of composite repair. Okay, so most of the aerospace applications out there actually are they have some sort of core into it. So those other techniques that we're talking about, this would still, though they would still work. The basics is still the same. But whenever you throw a honeycomb core into it, or a foam core into the middle of a repair, things get a little bit, they don't necessarily get a little bit more complicated, they just get different. And so here are three different ways that you could repair a honeycomb structure. So the first is an external repair. So this is like if you had a dent and you hollowed out that dent, put a plug in there, and then you put carbon fiber, your composite material, whatever it is, on top of it, and then vacuum bagged it in. So notice that the back side of that top graphic there where it says external, the backside of the part hasn't been removed or damaged. Now, this is really common with like floor repairs on helicopters, just where I've seen it the most. We would get it, somebody would drop something on there, it would cause a dent or a void, and we would come through, we would cut out a bigger area, build a repair core, slide it in there, and then put a patch on top of it. And you would vacuum bag that patch down, let it set up, and then come back and sand it so that way it's not super intrusive, not going to hang on anything. But you can't sand it too much because you have to maintain the original strength and structure of that honeycomb part, of the exterior part. But yeah, you'd still have like a little bubble there. Now, for our applications, we didn't really care. But you might have situations where that would be a big deal. Like if it was on a nice airplane and that was on the outside, you don't want to have this big, like, gaudy patch. And then it's also going to be parasitic drag and all that good stuff. So you might want to do something different. So something different is an internal patch. So let's say you were to knock a hole in a cowling or something. You'd come through, you would cut it out like a little circle, and then you would take your repair plug, stick it on there, but on the back side have your pieces that are effectively going to hold it in place and then adhere it to the rest of the cowling. You'd vacuum bag that down and make sure that it's set up, and then come back, sand the surface, repaint, and nobody, like, none's the wiser that there was ever any damage there until you look on the back side of the cowling and then you can see the patch. But that is another way to do it. The other way, and a lot more complicated, and it takes a skilled hand to do it, is a scarf. A scarf repair is you're basically going to cut you're instead of just cutting a straight hole, you've cut a bigger hole that tapers down. Now this is a superior repair if it's done correctly, because it helps disseminate a lot of the pressure off of those like 90-degree joints where like the simple hole was cut and the plug was put in there. And what's different is really that the repair core on an external or internal repair, transitions the whole repair. The scarf is just going to repair just the core, and then you have the different carbon fiber layups that will slowly transition upward. And so it's difficult to do because you have to match your carbon fiber plug that you're putting on top of there, your big patch piece, with the plies that are being repaired, and so it takes some skill, and you have to be very, very precise with what you're doing. So you don't see this as much. You see internal and externals pretty common, but scarf replacements are somewhat difficult, or somewhat less common to come across. But that is a way to do it. And no matter what you do, the structural repair manager is going to tell you what is authorized and what you want to do. And just you as the mechanic sitting there looking at it, it's like, okay, what is the smartest way to go about it? Because sometimes aesthetics really is important, and sometimes aesthetics is really not important, and sometimes it's really strength and quality of the repair. Like, let's say that was like a carbon fiber spar or something like that. You'd probably end up with a scarf repair because that's going to be the superior repair out of the three, and it's going to impart the most strength, but it also takes the most amount of skill, and there's a high degree of possibility that you could screw it up. And so maybe you're at the point where you're just like, well, we're just going to scrap that part and we'll replace it with a new one, which is probably the best if it's going to be like a big load bearing piece like a spar. But those are three repairs you'll come across, and then like the SRM, and then your own kind of experience will inform which one to execute. And this graphic just kind of shows you the two different approaches you could take to building that plug repair. You could just hollow out the damaged area with a partial depth replacement. I've never seen that actually happen. Usually, if the honeycomb is damaged, they'll go all the way down to the other ply, clean it out. You notice he's got kind of like a Dremel tool or some sort of rotary bit in there to clean up the little fragments of carbon fiber that may be there, because it's really, precision is really, really important here, because you're trying to prevent any sort of voids to form later on. And regardless, this repair is going to have a clock on it. Like, the repair is only good for so long, that has to be re-inspected and potentially re-repaired or the part replaced. My kind of go-to is that if we can replace the part when it comes to carbon fiber repairs, most of the time it's just better to replace the part. However, sometimes they don't exist. Sometimes they do exist, but it's going to take a lot to get them, or they're very, very expensive, and so it justifies the need to repair. But either way, this is how you do it. You're simply just going to cut the top plies down at an angle, and then take all the damaged honeycomb out, cut a piece that will fit in there as precisely as possible, and then begin your wet layup, vacuum bag, however it is you're going to approach fixing it. But yeah, that's what a plug looks like. Okay, so when we go to actually install that repair, there's actually a lot of little parts and pieces that we need to talk about as we start to do that layup. Now, obviously, like if we just go from the bottom to the top on this graphic, we have the repair. We've already talked about that. Now, the parting film that goes on top of that is going to allow you to have a nice, clean finish, and it's going to keep everything from effectively like sticking together. That's one challenge with dealing with the matrix material is that it's effectively like two-part epoxy. So I mean, it's going to want to glue to everything. So you have to control that one way or another. And parting film is a one way to do it. You also hear it referred to as like release film. It's the same thing. It's just kind of like this little, very small perforations in this like kind of plastic stuff that allows the excess matrix to pass through it into the bleeder material on top of it. That basically it's like a sponge that catches all the extra stuff, but it doesn't allow the bleeder material to adhere to the repair because that parting film is or that perforated film is in between the two. Now you have a another layer above. Now this one I've never seen this done, but this is an 8083, so we're going to talk the solid parting film up there, which is like another layer of release tape or film that goes over the top of that. They have a call plate and a heat blanket on top of that. So this is going to be like your hot bond kit setup. We won't do a call plate on this one. The reason why you would want that is that if the heat blanket gets so hot, you don't want it melting things. So you get to have some sort of like a standoff between the two of them. Then you have your breather material that goes over top of it. Once again, it's kind of like a sponge. And then your vacuum bag goes around. Now, the sealing material that goes around that looks like a little blue dot on that thing is actually just a sticky tack, like your first grade teacher would have used. But it comes in a long, kind of rectangular rope that goes all the way around the part, and you just press that vacuum bag material, which all is just like cellophane, on top of that. Then you have your vacuum probe. This one has a gauge. You don't necessarily need a gauge on there, depending on what you're repairing and to what standard and all that good stuff. It may call for it. It needs to be like super duper precise. Most of the time, you're just going to pull a vacuum on it, and it's going to just you'll the only time that I've ever actually used a vacuum gauge is whenever you're doing infusion. It'll drop the pressure down. Once you know that pressure is not moving down anymore, then you can tell there's a perfect vacuum. And so whenever you induce the resin into it, it'll suck up in there. That's why you would want that. Most of the time for repairs, you're not going to do that. You're just going to put the vacuum probe on there, turn the vacuum on, and just let it run. And it's going to continually pump out air as much as it possibly can. Now, those perforated film and the breathers and all that good stuff, the secondary purpose of it is allow air to go up into the vacuum. So it's going to pull air that would otherwise be in the repair, and it's going to pull that air out, and then it's and away from the repair, resulting in a higher grade repair over time. Now, once this is over with and done with, you're just simply going, it's all set up. You're turn the vacuum pump off, release the suction, and you just peel all this stuff off and it goes in the trash. It's pretty simple, pretty straightforward. You want to be careful whenever you're taking off anything that touches the part and go nice and slow, because what you don't want to do is just like rip it off, and if there's something that's hung, it just jacks it all up, and you have to redo it all, potentially ruining the part. But yeah, that's the kind of general setup that you're going to use. You're going to use it in the hangar to repair a part or design and build a part. But yeah, that is composites. It doesn't matter what kind that you use or anything else like that. That's the general approach to any sort of vacuum bagging repair or manufacturing that you're going to do. It's pretty simple, pretty straightforward. Okay, so the repairs that we've discussed so far are pretty involved. They involve taking a part off, cutting a part, building a repair and attaching it. The airplane's going to be down for a couple days at least, and typically that's just not this is just not how it goes. Typically, if someone owns an aircraft, they're real expensive. They want to keep them flying, and so what they're going to do is they're going to say like, hey, we have a void in this composite, or there's this delamination, or something like that. There has to be a way that we can expedite that repair. One way to do it is to inject resin into those voids. Now, and I've seen this done probably the most common type of a composite repair, bar none. When you're flying in like combat situations, like you can't, every one aircraft that's down is it's a major ordeal because that's less firepower that you have flying around, and so we would try to keep our aircraft up by doing these types of repairs rather than like kind of the heavy commercial mindset of like, let's take the part off, let's do it right, let's keep make it pretty and all this good stuff because we have time on our side. If time's not on your side, this is a way to go about it. Essentially, you're going to detect a void through a tap test, verify it through some sort of NDI, most likely it's going to be ultrasound, and you're going to say, okay, yeah, like right there is a void. Typically, it's going to be centered around like a dent. Sometimes it's not. Sometimes water got into it, or maybe it was a manufacturing malfunction or something causing a void. And what you're going to do is you're simply going to drill into that void. All right. Now on this one, they have like two drills, so like you have a place for the air to escape whenever you go to fill it with the resin. But then you're just going to take your resin gun and just fill it up. And like what that's going to do is just going to make a solid piece out of that void. Now this is you have to like be real careful about how you go or where you go about applying this sort of repair because this isn't an authorized repair on all different parts. Sometimes, depending on what that piece of structure does, you may have to replace the part. You may have to do very specific types of repairs with very specific types of inspections afterwards. But sometimes you can just get away with doing this, and so you would just drill a hole, fill it full of resin. Let the resin will show on both sides. You then take your scraper, you scrape it off. Usually, if you really wanted to be professional about it, you could vacuum on either side, if depending on what the situation is, or at least tape it off so that way nothing gets in that resin that's coming through, and then you don't have a chance of anything being introduced into the aircraft that's not supposed to be there. Just some way to seal it, and then come back usually within 12 hours or so, and that stuff is mostly set up because you're not doing huge quantities of resin with this. It's usually gonna be like little bits of resin, and so that is another way that you can go about repairing composites. Okay, another repair that you may see out there is a DVD repair. That's a double vacuum debulk principle. Effectively, what you're going to do is you're going to build a box on top of the repair that you're doing, and you're going to pull a vacuum not once but twice. What that's going to do is that the first vacuum is going to create negative space above the repair, and then the second vacuum is going to double down on it. It's going to turn around and start pulling air out of the repair, and then as that repair starts to or as that air bubble starts to come up, it'll accelerate and go into the secondary box. And then what that does is it prevents atmospheric pressure from holding air inside of the part. Now, personally, I've never actually seen anybody do this. It's out there. It's a way. It's probably done in very specific applications, and so the FAA wants it to be covered in this course. But I wouldn't look to see that's out there. But maybe one of you guys will get a job and you can call me up and tell me that I was wrong. But this is kind of rare in my experience. Okay, another one that's kind of rare is pre-peg patches. So effectively, these are just patches that are ready to go. They're already laid up, and you just pull the release film, stick them on the part. Probably apply a vacuum to it, and then just let it set up. So it cuts down on having to mix the matrix material and do all the cutting the patches and laying them up correctly and all that good stuff. Now, I haven't seen these, but I would be willing to bet I haven't seen these because I came up during a time whenever carbon fiber was still kind of the new thing and it hasn't really proliferated. You guys out in the fleet are very, very likely to come across these types of repairs because if it's probably a level of damage that's below a certain threshold, then on the line you might be able to put a patch overnight and launch the aircraft the next day to at least get it back to where to its next heavy check or whatever. But these are definitely out there and available for people to use if they are authorized by your operation, be it a 121, a 135, or a Part 91 aircraft. Now, most aircraft that have composites on them are going to call for what's called a bonded repair, and that's what we've been talking about. They're just going to be like rebuilding the part the way that it was intended to be built. However, there is a possibility that you could come across with an aircraft that has an authorized bolted repair. Now, this isn't necessarily anything that's like new or wondrous. If you were to pay attention to a lot of riveted aircraft, they will also have an alternative bolted repair or alternative bolt layup for instead of rivets. That's like a big thing whenever you go to take your IA that they're going to want to see you be able to discern. Like, can you use AN-3 bolts in place of said rivet. Composites, not really. It doesn't happen a lot, but it potentially could. So know that this is another repair that you could be asked to do. If there is, then there's going to be very specific instructions that you're going to want to follow, and you're going to end up drilling a lot of holes in there, and then you're going to end up taking fasteners, specific composite fasteners, to put into those into that repair. Which leads us to our next topic is fasteners in composites. Now, in sheet metal and wood and everything else, you generally will use the same kind of fasteners. They're AN bolts, regular like just MS standard bolts, things like that. Now, because of the nature of composites, there's kind of a different family of fasteners that you're going to end up using on aircraft. Now, that doesn't mean that you won't use bolts or anything else that's standard elsewhere, screws or anything else like that. You could. It just depends on the design of that aircraft and what that IPC calls for. But generally speaking, most composite structures have a unique family of fasteners that we're going to talk about right now. Okay, so before we really get too far into the particulars of composite fasteners, let's talk about the two big differences. One is just the general footprint that these fasteners are going to have. Generally speaking, you don't need them to be as big or grip as wide to hold together. The other, probably much more major difference is what they're made out of. Now, most like fiberglass and Kevlar fiber reinforced composites can cause corrosion problems when most fasteners are used. Composites reinforced with carbon fibers, however, are quite cathodic when used with materials such as aluminum or cadmium. The latter of which is a common plating for most fasteners used for corrosion protection. Now, that means that most of your fasteners are going to be made out of titanium, a very specific titanium alloy called Ti6 Alpha 1 Victor. That's the most common alloy for fasteners used with carbon fiber reinforced composite structures. Also, aesthetic stainless steel and super alloys, multi-phase alloys, nickel alloys. They also seem to work pretty well with carbon fiber composites. So you'll see them in places where you won't find titanium. But titanium is probably your most common one. Matter of fact, most people that have worked on carbon fiber airplanes will look at that picture right there and know exactly what they're talking about. It's very common on helicopters, especially. Okay, one of the first special fasteners that we're going to talk about is an ASP fastener, and so here they are in sequence. They're going to look. You would effectively drill a hole in composite, and you would slide it in from the back side. So you notice on Figure 1 there how it's flat on one side, and then it's not a threaded end. What those are like little kind of like, I guess, like grooves to grip with, and so that's the way it's going to stick through there. Then the sleeve component is going to thread onto the pin. So there's threads that are in between the ribbed end, and then there's like a little indentation right next to the top layer of the composite, and then there's going to be threads that's going to thread onto it. Now, on Figure 3, as a torque control tool tightens the sleeve, it's going to start to shove that sleeve in there, and it's going to basically tighten the collar around the fastener to make it super duper tight. Then once that's already on, the lock collar is going to be placed on the pin, and then you're going to use a special gun to pull off the pintail, and that's how they go on. Now, to remove it, you just have to drill it out, not unlike you would a rivet, but much more carefully because it's so flushed up with the composite, you don't cause any damage. The main thing here are these things are geared towards being a certain torque and a certain tightness, and still being highly reliable. The reason why the torque is such a big deal is that if you over torque a composite, it could be a bad thing. You could indent the top part of the composite, and it could cause a void, delamination, cracks in the matrix, that sort of thing. And so that's why these are one of the ones that get used a lot, but that's their big selling point is that you can't really over tighten them unless you just have the the settings wrong in your installation. But like by the simple fact of putting it on there, it's not like a torque wrench where you can just keep on going after it clicks. You're not going to have that problem. Okay, a real common one is going to be a high lock or a huck spin fastener. Now, they are lock bolts that are for permanent installation, so you're not going to be able to get them on or off. So it's a threaded fastener that incorporates a hex key in the react of the axial load during the swagging of the collar. When the swagging load reaches a predetermined limit, the pintail breaks away at the breakneck grooves. So basically, you spin it down and it snaps loose. Okay, so this is what it looks like to install one. The tool engages the lock bolt at the pintail. Then the gap's going to close. The collar swag begins. It's going to start to shove that thing down. Then the swag process is complete. I mean, it's sealed, and all that needs to happen now is the pintail needs to come off. So the pintail fractures there at point number 4, and it's pre-notched on there. You'll see it on there, and that's where they break off at. The tool anvil reverses off the swag collar, and the installation is over with. And what you're going to get is it looks like a flush rivet on one side and like a little bitty kind of nut plate looking thing on the other. Very very common on both composites and non-composites, but it's specifically used for composites simply because you can control the torque, and they are super super strong, so you don't have to worry about it being weak. So you don't if we were to use regular bolts and stuff, we would have to like go lower on the torque, so that way the torquing of the nut on the nut would put a lot of pressure on the composite itself. This won't do that, but it'll be much more stronger than a steel nut at a similar torque. Okay, similar concept, and you'll see these out there as well. Matter of fact, I think there's several of these on the Max, if I remember correctly. But anyways, these are Eddie bolts. They're made by Alcoa. Very similar at a certain torque. Those flanges on those locking collars will grip into the shank and create basically one solid kind of piece installation. But yeah, same idea. Control the torque, but make sure that it's still strong and does the job that you're supposed to. Eddie bolts. Okay, another one is the Cherry's Easy Buck hollow rivet. Cherry Max are used all over the place. These are in particular are made for composites, and they're made out of titanium to cut down on the corrosion. The main advantage these offer is that you can get the same strength as you would with a solid rivet of about the same size and same material, but their design allows you to use a lot less force in installing them. Whereas with a solid shank rivet, you're having to buck it, and there's a lot of like impact that goes onto it. If it's just aluminum, as long as you're bucking it correctly, you don't really have anything to worry about. You do with composites for sure, and then the excess vibration is probably not necessarily good for it anyways. With these, use a rivet squeezer. So essentially, you just install them, slide over there, pull a trigger, and it pow, and it just squeezes it for it. It's real super easy, super simple to do. Yeah. Okay, this is a Cherry Maxi Bolt, very common out there. This one, well, this particular one may not be as common because it's all titanium, and you generally, once these go in, you don't ever really have to replace them because the corrosion is basically minimal. It's usually going into carbon fiber, which is super strong, and this is super strong. So the only time you're really going to have to replace them is that if there's a wreck, some sort of crash, damage, something like that. But anyways, this works just like any other Cherry Max rivet. The gun's going to pull it. That little collar on the far left hand side is going to enter into the shank, cause it to bulge out like a regular rivet. The pintail is going to break off, and you're going to go on to the next one really quick, just a little pow, and then you're done. So Cherry Maxi Bolt by by Cherry Aerospace, very common out there. Okay, so this is what we're going to end with. Drilling, cutting, or otherwise modifying a piece of carbon fiber, aramid fiber, fiberglass, you name it. This goes for carbon fiber, definitely for aramid. Fiberglass is not as big of a deal, but if you don't have the right type of drill bit, it will dull it out. It will cause the piece to heat up. It can cause ply damage, delamination, and generally the hole is not going to be the best for you to install whatever you need to on there. So that being said, make sure that you use the appropriately rated cutting materials on that carbon fiber, because if not, you're going to come to regret it. All you're going to do is make a mess out of the job, you're going to ruin your tools, and then you're going to start over at square one, usually like behind in the red this time, rather than making a straight profit on your work. So that being said, make sure you use the right tool. Now, the other bit of it is don't inhale that carbon fiber dust. It's really bad for you. You want to, anytime you're cutting or modifying anything like this, wear a respirator, a mask, something to keep that stuff out of your face. Don't work in enclosed areas where it's gonna turn into like a little dust cloud around you or anything else like that. Reason being is that stuff is a carcinogen. You don't want it in your lungs. Bad news. There's a lot of mechanics out there died early deaths from mishandling materials. Carbon fiber is probably not one of them because it's still fairly new. But don't be one of those ones that ignores the safety and ends up getting put in the ground a little bit too early. Other thing on this picture in particular, see how he's using blue tape to mark his holes out. You want to do that. The reason being is that as you cut into those fibers, remember it's still fiber. It may be encased in matrix and feel super duper hard, but at the end of the day, it is a carbon fiber thread going through there that's actually doing the work. If you use blue tape, it will help keep them all in place, and you won't get so much of that little fuzzies around the hole. And if you drill with the right tool and drill the right way, you generally shouldn't get those anyways. But this will also help catch any kind of stray drill marks or anything else like that. And it just does a more professional job. When you're done, take some isopropyl, put on a rag, wipe it all off, get all the fingerprints off, all the dust, and any adhesive left over from the tape, and you'll have a professional looking piece of carbon fiber to do your installation. All right, so with that is all of all the knowledge code information that you need on composites, and that will conclude 1352. See you in the next class.